Hello everyone. So in this video we are going to talk about line reflection problem. This is a Leetcode problem. So let's go through what exactly is the problem statement. So if you see, right, it says we are given n points on a 2D plane. By 2D plane we mean we have x and y. Basically it's x y plane or yz plane, right? It has basically two axes. Now find if there is such a line parallel to y-axis that reflects the given points. So let's see what exactly it says. It says we would be given some n number of points. Say I'm given some point here, 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 something like this, right? And then I am asked if it is possible that I can find some line parallel to the y-axis. By parallel to y-axis, what do I mean? Any line like this. This is our y-axis, right? So any line parallel to it. They are asking if there is such a line, then please find that line. It does not say find that line. It just says output if such a line exists or not. So one thing before beginning, right? So there is one concept which is important to understand before we begin the solution of this problem is any line parallel to y-axis would have an equation y equal to some constant. Sorry, x equal to some constant. Right? So if you see this equation, right, this line, right, the equation for this is x equal to 0. Similarly, if this was 1, this was 2, this line would have been x equal to 2. You can see, right, on this particular line, each and every point has x value equal to 2, but different values of y. Okay, now going forward, so let's take an example, and after let's see how we can go about and solve this problem. So let's say I have points, okay, let's say the points given to us are minus 2 comma 4, minus 2 comma 1, minus 1 comma 1, 0 comma 1, 0 comma 2, 2 comma 1, 2 comma 2, 3 comma 1, 4 comma 1. Okay, so these are the points. Let's ignore this point. So let's say these are the points that are given to us. So before understanding that, I'll just quickly plot them on a xy plane. Okay, so minus 2 comma 1 would be somewhere here. Okay. So this is minus 2 comma 1. Let's name these points, right, instead of so minus 2 comma 1 is here, minus 1 comma 1 is here, 0 comma 1 here, then 0 comma 2, 2 comma 1, 2 comma 2, 3 comma 1, then 4 comma 1. Okay, so now we know what these points are, right? Now are you able to see that we are clearly able to see, right, that this line, if we see this line, then all these points are basically reflection of each other. If you see carefully, right, so this point is clearly a reflection of this point, this point is clearly a reflection of this point across this line. What do I mean by reflection? Say if you are standing in front of mirror, right, how do you see that how do you see your mirror image? If you're standing here, you see that inside the mirror also you are kind of standing here, like it's not like your face is just in front of the mirror, right? You are able to see that depth. So here also, this is like their mirror images across this line. So now how to find that there is a line possible such that there are reflection, like for every point there is a reflection in it, right? So there are two things here. So if you see all these points, right? So if you see the left extreme and the right extreme, what is the left extreme? Minus 2 comma 1, and the right extreme 4 comma 1, right? For example, there could be a case where there are two right extreme. So we'll take that up later. Let's just consider that there is one left extreme and one right extreme, right? So clearly, if you get the idea right, so they are the only possible, like if it is if there is a line across which reflections are possible for every point, then these 2 points can only be that mirror pair, or these 2 points can only be their reflection, because they are extremes, right? So for this point, this cannot be a mirror image. For a left extreme or for a minimum, only max point or right extreme can be a mirror image, right? Say for this point, if there are multiple candidates, only the farthest one can be, if this is the farthest one, so only these two can be mirror images of each other, right? So this is kind of main crux to solve this problem. So so we are clear till now, right? Only a minimum extreme or the left extreme can be a mirror image of a right extreme across a line, right? So let's say that these points are x1 comma y1 and x2 comma y2. So this is a line parallel to y-axis, some line parallel to y-axis, right? So first criteria for both of them to be mirror images are y1 equal to y2. This is the first criteria. Second criteria is like there is no second criteria, right now. Just see, like these 2 points are mirror images. I'm saying these are mirror images, so I can say that the y coordinates are same. So it's some x1 comma y and x2 comma y. Now if it is true that they are mirror images across a line, then what would that line be? If you see, if this is that line, right? If you see this point, it would be some x comma y. This is x1 comma y. This is x2 comma y. This would be x comma y, let's say. So we can also say that this distance is equal to this distance. See, like if you are standing in front of the mirror, if you are standing at k distance from the mirror, your mirror image would also be standing k distance from you, right? So same thing here. So if this distance, if you see the distance of this x1 comma y point from x comma y, and you see the distance of x2 comma y from x comma y, they would be same, right? So can I not say that x minus x1 is equal to x2 minus x? This we can say, right? If you are not able to directly get it, you can also use distance formula. Since the y coordinates are equal, right, the y's would get cancelled. So I can say that 2 into x is equal to x1 plus x2. I can say that x is equal to x1 plus x2 by 2. Even if I were not to use any equation, right, I could say like it's kind of intuitive and kind of self-explanatory that the mirror image would definitely lie in between of these 2 points. So now we know that x is equal to x1 plus x2 by 2. One more thing I told you in the beginning, right? So this is not asked for in the question, but if you want to find the equation of this line, right, it is x equal to k. and this k here is nothing but this x itself. So the equation of this line would be x equal to x1 plus x2 by 2. But this is something extra. This is not needed in the question. Now coming back to our question. So far we know one thing. If x1 comma y1 and x2 comma y2 are mirror images across x equal to some constant, then this constant is equal to x1 plus x2 by 2. Second, y1 is equal to y2. So these are the two conditions that we have discovered so far. Now falling back to where these points are, right, I'll just copy them and bring them down. Why is pasting so hard? Anyways, so if you see this, right, so if you see these points, right, so say for example I pick any point, or if I know, like, there are two possible ways to it, right? Either you assume the value of this constant and see that for every point are you able to get a mirror image. Say k could lie from x minimum to x maximum, right? Say for example, what I meant was, this is our xy plane. There is one point here and one point here, right? And there are infinite n number of points in between. So if I say that there is one brute force method, right? Let me assume that the mirror image, like the axis to which across which all these points are mirror images, is this. The equation of this could be some x equal to minus 3. I could check that for x equal to minus 3, am I able to find a point corresponding to this point from the given points? And how I am going to do that is, I am again going to use this equation only, x equal to x1 plus x2 by 2, or 2 into k is equal to x1 plus x2, or the x2 point is nothing but 2k into x1, 2k minus x1. So this is one method. But second, this, if we discuss the complexity of it, right, it would be some on square, because for some m possible, or this m into n, this m is basically max x minus min x into n. So for every possible value of k, right, I'm going to check that for every point given to us, is it possible to find a mirror image or not. So hence this complexity. Now there is a little more optimized solution to it, if you saw it clearly, right? So I told one more thing in the beginning or in the middle, right, that for a min x, only a max x can be a mirror image. So if that's true, then we can directly see now, like, if that's true, then we can directly find k, which is nothing but min x plus max x by 2. If we know k, then there might be several points. Now we already know that if a line exists, then it's definitely this x equal to k only, and k is this only. If we know, then why do we have to search for each and every possible k? Then our complexity would reduce to on. So from a square complexity, you convert it into a linear time, right? Now one question that might arise is, there might be several points with same x value but different y. Then you have to choose the one for which y is same, which is at the same height, and that is only one possibility, right? So until unless the point is same, both x and y cannot be same, right? It's like the same point. Yes, so this is the whole idea for solving this question. if I were to sum up, right? So what I'll do is, first I'll find the min x comma y and max x comma y. Then k is equal to x min x plus max x by 2. Then for every point, check if a mirror image exists. And how do I check that? I am again going to use the same equation, right? K equal to x1 plus x2 by 2. Now if I know x1 and k, I can find x2, right? So if I'm able to find a point x2 comma y such that x2 is equal to 2k minus x1, then there exists a mirror image for x1 comma y, right? So this process I'm going to follow for each and every point and see if it holds true. In the part 2 of this video, I am going to directly solve this question, and if you want to see the code solution for this, then stay tuned.